Okay, so for this recording, we were looking at page 241, question 3, trying to create a level 4 response. And there were elements of the think aloud that were missing. And some of you were talking about how you wanted to use patterning in your response, but you weren't sure how to apply it. Well, if you go back and look at Rodrigo's problem, he was trying to create a 0.5 meter squared mosaic using centimeter squared tiles, and he wanted to know how many centimeter squared tiles he would need to build the mosaic. Well, patterning application that we used before in prior questions, like in this one, could be applied to the question that we're working on now. So if you go back and check this one, in this question they're talking about the relationship between decameters and millimeters. And it involves following a pattern of steps when we divide by 10, because as we move from a unit that's larger to a unit that's smaller, the size of the unit is being decreased by a factor of 10 each time. And what's missing in here is decimeter, by the way. Now, if the units are getting smaller, that means that the magnitude of the number is getting bigger. This pattern relationship could be applied to your solution in your think aloud. How? Well, if we're comparing centimeter squares to meter squares, there is a relationship that we're jumping using place value. Now, if we go from meter to centimeter, when we look at the magnitude, what happens? Well, here it's 15.2 meters becomes 152 centimeters. That same relationship, which is increased by a factor of 100, the same relationship is being applied when we do an area calculation or an area conversion. From meter squared to centimeter squared, well, now it's not just applying meter, but meter times meter. And here we're talking about zero movement. Move the decimal point over one space, over one space in terms of place value columns to the right for every zero in the conversion, because each place value column represents a factor of 10. So every time you multiply by a factor of 10, you're moving one unit conversion, and you're also moving one place value space. Sorry, 1 meter square, not a cube. How many of those tiny little centimeter squares are found in this 1 meter square? Well, if we go to Rodrigo's problem, he's only doing half of the meter square, not the whole thing. But the relationship that we were describing or looking at is similar, because we take our answer and just divide it by 2, which could ultimately be part of your plan. So if these squares represent squares that have 10 centimeter side lengths, meaning we have 10 of these centimeter squares all attached side by side to create a 10 by 10 panel, 10 centimeter by 10 centimeter panel. That means each of these little panels will cover 100 centimeter squares, or you need 100 centimeter squares to cover this size. So how many of these little panels will fill the entire meter square section? Well, you would need 10 of these to go across, and you can check by drag and dropping them in. And this, what I'm doing right now, is using the planning or the problem solving strategy of making a diagram and applying the diagram. And as I'm speaking, I'm describing my think aloud. Now, what I'm saying could be what you write, or it could be what you say if you present your work this way. So as I drag and drop my panels in, I'll prove that there are 10 panels across and 10 panels down. And since each panel represents 10 centimeters in length, that means I need to multiply 10 centimeters in length, or sorry, 10, 20, 30, 40, 10 times 10, which would give me 100 centimeters in length across, which makes sense because this is a meter square. And then I'd have 10 centimeters, 20, 30, there would be 100 centimeters in side length down, because it would be 10 centimeter side lengths of each of those panels. So 10 centimeters per panel, 10 times 10 is 100. So there's 100 centimeters here, 100 centimeters here, 100 times 100. Well, 100 times 100 is a factor of 10,000 now. That means that 1 centimeter square, a little centimeter square, will take up a small spot. It'll take up 1/10,000th of this entire meter grid, or meter square. Now, let me see if I can help add a little bit more information. So basically what we've been talking about is that the relationship between centimeters and meters is a factor of, if you go from meter to centimeter, you're going to be multiplying by 100. And in place value, that means you're moving the decimal point 2 spaces. So if we started at 1.0 meters, when we multiply by 100, it involves us moving the decimal point 2 place value spaces to the right. And then we have to add a 0 here. That's where the 100 comes from. So when you say moving the decimal, well, what does it actually mean? You're actually multiplying by 100, moving the decimal point 2 place value spaces to the right. And that would help you find out the relationship between 1 meter and 100 centimeters. Well, when we look at area, it's not just 1 meter, but it's 1 meter times 1 meter, because that's the area. Does that make sense? So if that's the case, and we know that 1 meter is equivalent to 100 centimeters, and to get there we need to multiply by 100. Well, that means we're going to have to multiply these two to find an equivalent area for 1 meter squared. And how do we do that? Well, in order for us to multiply 100 times 100, we can use another pattern. Anytime you multiply by 10, the pattern is you will be adding a 0. So if we were going to multiply by 10 times 4, we'll end up with 40. Now if we do 10 times 4d, there's another 0 in the question, meaning the number increases by a factor of 10. And when you increase a number by a factor of 10, it's just like moving the decimal point 1 space to the right. So here, we're doing 100 multiplied by 100, which is the same as, if I take one of these zeros and move it down here, it's the same as 1,000 multiplied by 10. And whenever you multiply by 10, you just move the decimal point 1 space to the right. So it would be 1,000, move the decimal point 1 space to the right, and you get 10,000. Now, another pattern that you could see is that if you have 100 multiplied by 100, how many zeros are there in the question? That's how many zeros there should be in the answer. Why? Each 0 represents a multiplication of a factor of 10. 100 is 2 factors of 10. 100 is 2 factors of 10, meaning we're going to be multiplying by 4 factors of 10, which is the equivalent of 1 factor of 10, 2, 3, 4 factors of 10, 10,000. This helps us find the relationship between meters squared and centimeters squared. I hope this helps.